Now, starting with electrical drawings, what is the objective of an electrical drawing? Firstly, it's an engineering drawing for the electrical engineers. The symbols used in electrotechnology and governing standards that we use, the symbols on that drawings. We can get a single line or a free line diagram on the drawing. We also get cable and wiring drawings. We get layout drawings, and one of the things that we use mostly today is CAD drawings, computer-aided design drawings. That's what we're not drawing by hand anymore. We're now using the computer to generate these drawings for us. Now, what is the relevance of drawings to engineering? Graphics are one of our most effective ways of communicating one's ideas as a good recognizable picture, and that will then reduces anything that's unclear while discussing the project. Engineers and your technical personnel is also associated with an engineering organization, which will then use drawings to convey the ideas and the plan that is necessary for execution and completion of any project, which can be construction or assembly of components or systems. Now, only standard symbols and abbreviations should be used. So anyone that pick up your drawing must be able to understand that. Now, drawings is used as a tool at various stages of working. Firstly, the tendering stage. This will then help in procuring an accurate quote. Otherwise, the people can't give you an accurate quote. It will also help in avoiding future disputes arising out of discrepancies. In the design and engineering stage, this drawings helps engineers to work out the detailed bill of materials, which is then further used in the procurement department. During construction and the assembly stage, the drawings in this stage help the technical personnel at the construction site. During operation and maintenance stage, the drawings help in day-to-day operation and also in rectifying any anomalies arising in the system. So drawings is necessary right through all the stages that we are working in the industry. Now, here's an example of drawings in an engineering organization. So there are certain ideas, but for us to put the ideas into practice, the first thing that we do is to put something on a drawing, and from this drawing we can actually then manufacture something. You can get a finished product. We can start distributing the product, and then we go out to the customers, and then feedback from the customers will then give us changes and improvement of our original idea, which is now our product. So here you can see that drawings is the first step in the whole process. Now, let's first look at the key single line diagram. Now, during our preliminary project designing of any project, the key diagram that we use is a single line diagram. It's also called a one line diagram, and a number of subsidiary single line diagrams. Now, this set of single line diagrams form the basis of all electrical work that's carried out in the project, and it also shows all the pertinent information about the sequence of the circuit. The purpose of the single line diagram is to show sources of power, electrical equipment, electrical drives, and system details, as well as fault levels. So that's the single line diagram. Then we also get what we call electrical layout diagrams, and this is an exact graphical representation of the layout of various fixtures, equipment, utilities, and buildings. And this is intended for engineering and calculation, again, of the bill of materials. What's the types of electrical layout drawings that we get? We get lighting, switchgear layout, generator and other equipment layout, earthing layout, lightning, not lightning, but lightning, cable layout, conduit layout, cable tray layout, and also area classification drawings, specifically to identify the hazardous areas. So that's all the electrical layout drawings. Now we can also have these drawings on a single or a multi-sheet, and it's quite often the layout of the drawing that it's large and you can't put it on one single sheet, so that's then carried over to the next sheet. Now all the sheets have the same drawing number but different sheet numbers that you can see they all belong together. Now any important applications of multi-sheet drawings is our electrical schematics for the control panels and the low and medium voltage switchgear assemblies. They all will necessarily have more than one drawing. Now, which are the drawings that need symbols? Now, symbols are alphabets or the basic components of engineering that we use in terms of graphics. So it plays a key role in the development and maintenance of the drawings. Now, the primary consideration for any organization is the consistent interpretation of the drawing symbols. So there is some standardization of symbols, and that's why if anybody in industry pick up that drawing, because there's standard symbols, you will be able to understand the drawing, because from that you can make plan, and drawings is much more understandable because of the fact that we standardize. Now, what is a single line diagram? It's a diagram that shows single lines and symbols a simplified layout of a three-phase electrical system. So the single line or the one-line diagrams get their name from the fact that there's only one phase of a three-phase system that's shown, and only one line is used to represent any number of current carrying conductors. We use standard symbols to represent our components of power systems, such as transformers, circuit breakers, generators, fuses, and switches. That's on the single line diagram. What is the information that we get on the single line diagram? Incoming cable sizes, source details, in-through bus tact symbol and ratings is marked on the type of switching devices and the nominal ratings, the CT and the potential transformer ratio, the burden, the accuracy class, the instruments, the relays, the earthing of the incoming and outgoing feeders, surge arresters for incoming feeders, legend and legend drawing reference, board designations and device designations. So although it's a single line, it gives us a lot of the information on the equipment itself on the single line diagram. And here is an example of that. So although this is three phases, what we see is only a single line, but we see all the devices that's connected to this specific lines, and it also gives us the physical information of that line or that transformer, whatever is then shown on that line itself. So that's a single line diagram. Now here is an example of a three line diagram. So these are three phases, but now it's shown as three lines or four lines with the neutral, and not one single line anymore like in the previous diagram. Now what is the difference between single line and three line diagrams? Single line diagrams provides a basic roadmap to the interconnections of your electrical system and serves as a building block from which all types of system analysis are based. So we can do proper system analysis by that. If you compare it to three line diagrams, so these are prepared as the result of further working on the basis of the single line diagram. So we're extending the single line diagram on our three line diagram, and this provides details for your electrical wiring connection. Going back to the one line diagram, it's part of the initial plant electrical design and also used in your tender document. This is part of the detailed design in your three line diagram, and it's usually after the tendering stage that you get that diagram. Single line is then used for working out panel schedules, while the three line is used for control design, circuit diagrams, control circuits. It's for the more detail of that. A single line diagram is a simplified notation for representing a three-phase power system, And on your free line, you've got all three conductors of your three-phase system is shown individually, and all the details of the power and the control circuits are also shown as the actual field connections. So that's the difference between single and three line diagrams. Applications of three line diagrams. It's for detailed design of your power and control circuits, as we've mentioned. Phase sequencing representation, displaying differential relay settings, displaying potential and current transformer settings, and maintenance and circuit repair can be done from the three line diagrams. Then we also get plant cabling system drawings. Your cable drawings are part of your detailed design and your engineering activity of a project, and they are normally prepared on the basis of single line diagrams, so you use that single line diagram as an input. The wire and the cable system are designed for long life with a minimum of service interruptions, and we've got specifications that provides overall guidelines in planning, designing and installing of wire and cable systems in a plant. So that's our plant cabling system drawing. Now we can classify the cables in terms of power and lighting. Conductors include circuits from the station service, branch circuits and control circuits from the distribution center, feeders to your lighting panels and lighting branch circuits. Then what we also have is control cables. Will include your station control and indicator circuits from the control room switchboard, your unit instrument boards, your exciter cubicles and your secondary control centers. Then what we also have lastly is analog and digital signal cables for the instrumentation signals. So there's different type of cables that we get going from the top down. So there's the power, and then on the control side the analog and digital signal cables is then also lower power rating compared to the power cables. Now what's the purpose served by the different types of cable drawings? It will then show you on those drawings the power connections between the various electrical devices. It will show you the route for the conductors and the mechanical support systems, like for instance trays and conduits. It's to show the electrical interconnections between the different systems, and to help the designer work out the optimum conductor sizes with respect to the connected load. It works also as a basis for development, and it works as a basis for the spacing management for the cable pathways. And this is a mandatory part of the bill of materials, as well as the price schedule for calculations during the tendering stage of any project involved electrical system. Then wiring diagrams. Wiring relates to the connection for the utility equipment, such as the lights, the fans, the socket points, etc. In another plane, it's the internal connections within the control panels that you'll get on the wiring diagram. What's the purpose of your wiring diagrams? Is to show the power connections. It shows the internal schematic connections within the control panel, and to show the control connections between various control components. What's the difference between cabling and wiring diagrams? Wiring diagrams are referred to utility power connections and are often schematic in nature and carry less detail about location and routings. If you compare that to on the cable side, there's more detail to have exactly followed by construction crew, and therefore have to be complete and self-contained in all respects. When going back to the wire diagrams, it will give us the internal wiring diagrams of a panel, as we've mentioned before. It also identifies the wires by wire numbers or color coding that you'll get on your wiring diagram. Here's an example of a cable layout that gives you the information as we've said over here. So it gives us all the information on where the cable should go, compared to wiring layout, which is in the physical wiring connection between all the panels. So there's an example of the two. Then we also have a panel internal wiring diagram here. So it gives us the wiring details for the power circuits, the wiring details for the control circuits, the coil and contact cross-referencing details, and even the terminal block details is all included in this panel internal wiring diagram. Then we also have terminal diagrams. These provides details of the terminal strips for junction boxes. Terminal diagrams also details for the terminal number and the corresponding serial number of the outgoing cable to be terminated at a particular terminal. So that's another diagram that we use to show us the connections. The purpose of layout drawings is to give us an accurate development of the conception of the design. So without that, we cannot in practice or in industry actually to do the layout or the wiring. The essential elements are developed and the geometry of the equipment is dimensionally defined by this. The general shape of each equipment member is approximated and calculations are carried out simultaneously, which actually determines the actual sizes. So several layouts may be required for one specific plant. The plant layout drawing and the plot plan. Okay, the plant layout refers to arrangements of the physical facilities, and the plant layout drawings or the plot plans are considered key documents to projects, and it's normally initiated at the pre-contract conceptual and development stages. And the plot plan becomes a universal document used by all groups. Now this is the same with any electrical design as well, because you do a layout even on PC board level. Same principles apply. So there's an example of a plant layout diagram that shows exactly where all the different pieces of equipment must go and how they interrelate. That's another example. So the design of the electrical equipment is prepared once we have the single line diagram and the equipment and the load schedules that's been finalized, and then we have the general arrangement and foundation details, which forms the basis of the finalization and electrical equipment layout. So that's the detailed drawings that we will then use in industry. Then also the types of earthing system layout drawings that we get. It gives us the details of the earthing network. It can also include substation earthing grid and detail and cross-sectional drawings for dividing points, equipment earthing details, inspection pits for earth electrodes. That's all part of your earthing system layout. So there's an example of plant earthing system and the substation earthing grid on this drawings that you see over here. Then lighting protection system drawings, the lighting protection system grid, the air terminal details, the down conductor details, the ground terminal details, as well as the surge arrestor details that we want to use with the lighting protection. All of that is then part of the lighting protection drawing, and it gives you all the details for lighting protection. Then we also have lighting layouts. Now this should be very clear. Illustration of where the luminaries placement and application intent. So the layouts with circuiting, panel board assignments and control methodologies must appear on the drawings. You need exact lighting fixture positions, node sections that provides guideline for installation and mounting, also used to display luminance calculation data, and conduit schemes are prepared separately for the installation of the conduits itself. So there's an example of an indoor and an outdoor lighting layout. So there's the indoor lighting layout and the outdoor layout, as you can see over there.